This is the Module 3 Engineering Mathematics, which was done in July 2022. Engineering Mathematics 3. Okay, so the paper is 3 hours. Okay, this paper is done by Diploma in Mechanical Engineering. This is production option, kuna plant option, and then Diploma in Automotive Engineering, Diploma in Welding and Fabrication, and then Diploma in Construction Plant Engineering. Okay, so we can here we have question 1a. Given that matrix A is given by this, they want us to show that A squared times A inverse equals to A. The question is 12 marks. Okay. Solution. They are saying that A equals to -1, then 1, 1, 1, 0, -2, 1, -1. So that is, so they want us to show that A squared times inverse of A is 1 equals to A. Now, first of all, we shall be required to get A squared, and also after that we shall also be required to get the inverse of matrix A. Now, A squared is the same as A times A, which equals to -1, -1, 1, times so we multiply A so this equals to, so we multiply row and column, so it will be -1 times -1, so we have -1 times -1 plus, we take -1 times -1 times 1, we multiply with this one, then plus 1 times -2, 1 times -2. Like that. So we are done with the first element. We go to the second element. So it will be -1 times -1, -1 times -1. Then we have -1 times 1, this plus -1 times 1, this -1 times 1, then plus 1 times 1. So we are done with the middle element. We go to the last element. It will be -1 times 1 times 1 plus -1 times 0 plus 1 times negative 1. 1 times negative 1, like that. So we are through with the first row. Now we come to the second row. It will be 1 times negative 1, 1 times negative 1. Let's use dot times 1, like that. And then we have 1 times 1 plus 1 times 1, and then plus it will be 0 times negative 2. 0 times negative 2, like that. We go to the middle values, so it will be 1 times negative 1, 1 times negative 1, plus 1 times 1, this is 1 and that, then plus 0 times 1, 0 times 1. We go to the last, 1 times 1, 1 times 1, plus 1 times 0, 1 times 0, plus 0 times negative 1. Okay, we are done with the second row. The last row, we shall have negative 2 times negative 1, negative 2 times negative 1, plus 1 times 1, 1 times 1, plus negative 1 times negative 2. Move on to the middle values. Negative 2 times negative 1, plus 1 times 1 is 1 times 1, then plus negative 1 times 1, negative 1 times 1. Then lastly we have negative 2 times 1, negative 2 times 1, plus 1 times 0, plus negative 1 times negative 1. This equals to this negative 1 times negative 1, we have 1. So this is 1. We have 1. Negative 1 times negative 1 times 1, it will be minus 1, then minus 2. Then here we have 1. Negative 1 times negative 1, so we have 1. Then negative 1 times 1, minus 1. Then 1 times 1, it will be plus 1. Then here we have negative 1 times 1, have negative 1. Negative 1 times 0, we have plus 0. Negative 1 times negative 1, we have minus 1. The next row, 1 times negative 1, we have negative 1, plus 1, 1 times 1, then 0 times that, so it will be plus 0. 1 times negative 1, we have negative 1, plus 1 times 1, we have 1, and 0 times 1, we have plus 0. 1 times 1, we have 1, plus 1 times 0, we have 0. 0 times negative 1, we have 0. Then we are here, negative 2 times negative 1, we have 2, plus 1 times 1, it will be 1, then plus negative 1 times negative 2, we have plus 2. Negative 2 times negative 1, we have 2. Plus 1 times 1, we have 1. Then plus negative 1 times 1, we have minus 1. Negative 2 times 1, we have negative 2. Plus 1 times 0, we have 0. Plus negative 1 times negative 1, we have plus 1. So this equals to, now we have 1 minus 1 minus 1 minus 2. So here we remain with negative 2. Here we have 1. Because we have 1 minus 1 plus 1, we remain with 1. Here we remain with the negative 2. So minus 1 plus 1 plus 0. So here we remain with the 0. Negative 1 plus 1 plus 0, that is 0. Here we have 1. Here we have 5. 2 plus 1 minus 1, we have 2. Then you minus 2 plus 0 plus 1, we have minus 1. So this is our a squared. This is our a squared. So the most important thing we need to know that when you are multiplying matrix, you multiply row and column, and this is the working. Therefore, we are saying a squared equals to this matrix. Now that we have a squared, we now need to get the A inverse. Now, A, we are saying that equals negative 1, 1, 1, 0, negative 2, 1, negative 1. We need to get the inverse, A inverse. So we shall start by getting the determinant of this matrix. So determinant of matrix will be equal to, now we shall have negative 1, then the minus of this negative 1 will be 1, 0, 1, 0, 1, negative 1, then minus 1, block this row and this column and this row, so that we have 1, 0, negative 2, negative 1, then plus this 1, then into the minus of this, we block this. This is 1, we block this column and this row, so we have 1, 1, negative 2, 1, 1, 1, negative 2, 1. Then we expand this, so we have negative 1 into negative 1 times 1, we have negative 1. Then 1 times 0, it will be minus 0. Then minus and minus plus 1 into negative 1 times 1, have negative 1, minus 0. Then plus, we have 1 into 1 times 1, we have 1. Then minus 2. Negative 2 times 1, have negative 2. This equals to negative 1 into negative 1 plus 1 into negative 1, then plus 1 into, this will be now 3. So this equals to, when you multiply negative 1 times negative 1, we have 1 minus 1 plus 3. This equals to 3. Therefore, we are saying determinant of A equals to 3. Now, after getting the determinant of 3, we are now required to get the matrix of cofactors of this element. Okay, can say let the matrix of cofactors be C, which equals to A11, A12, A13, A21, A22, A23, A31, A32, A33. So this is the element of the matrix of cofactors. Now we need to get all these values. Now A11 equal to, now A11 is this one, and the place sign of this first element is positive, so we shall have positive, and then the minus of this element 1 is 1, 0, 1, negative 1. Then when we expand this will be equal to the place sign is positive into negative 1 times 1, you have negative 1, minus 1 times 0, it will be 0. So this equals to negative 1. So A11 equals to negative 1. So we have this. We can move on to get A12 equal to, so is this element, the place sign of this element is negative, but the minus of this, we block this column and this row, so we have 1, 0, negative 2, negative 1. This equals to, the place sign is minus into negative 1 times 1, we have negative 1, minus negative 2 times 0, we have 0. So this equals to negative and negative with positive, so this will be equal to 1. So we are done with this. A13 equals to, so the place sign of this is positive. The minus of this, we plug this row and this column. 1, 1, 1, 1, negative 2, and then 1. This equals to, the place sign is positive into 1 times 1. 1 times 1 we have 1, minus negative 2 times 1, we have negative 2. So this equals to 3, equals to 3. So we are done with this. So we come to A21. So A21 is this. So the place sign of this is negative. The minus of this element, we plug this row and this column, so we remain negative 1 and 1, and then 1, negative 1. So the place sign is minus into negative 1 times negative 1, we have 1, minus 1 times 1. So this equals to 0. We are done with that. A22 equals 2. So this A2 is this one. So the place sign of this are positive, negative, positive. So it will be positive. The minus of this element will block this column and this row. So we remain negative 1, positive 1. And then we have negative 2, negative 1. This equals to plus into negative 1 times negative 1, we have 1, minus negative 2 times 1, we have negative 2. So this equals to 3. So we are done with that one. Then A23 equals 2. So A23 is this one. So the place sign of this positive, negative, negative. So it will be minus into, we plug this column and this row, so that will remain -1, -1, and then -2, and then 1, minus 1 times -1 have -1, minus -2 times -1, we have 2. So this equals to negative, so this will be 3. So we are done with that one. So we move on to A31. A31 equals to, so the place, so A31 is this element, positive, negative, positive. So this plus into, so we plug this column and this row, so we remain with this. So we have -1, +1, 1, 0 equals 2, plus, then 0 times -1, you have 0, minus 1 times 1, you have 1. So this equals -1. So we are done with this one. And then we have A32, this equals 2. So it's this element. So the place sign here is positive, negative, positive, negative. So the place sign is negative. Then the minus of this element, we plug this column and this row. So we remain with this -1, +1, +1, 1, 0. So 0 times -1, you have 0, minus 1 times 1, you have 1. So this equals to 1 because we have negative here, negative will be positive. So we are done with this. Then we have A33, the last element. The place sign of this is positive. So we plug this column and this row, we remain with -1, -1, 1, 1 equals plus into 1 times -1, we have -1, minus 1 times -1, we have -1. So this -1 plus 1, this equals to 0. So we have all now the elements. So C now equals to, we can now collect all this. So we have -1, we have 1, 3, we have 0, 3, 3, then we have -1, 1, and then 0. So now this is the matrix. This is now the matrix of cofactors. Now we can transpose this matrix. We can get C transpose. We simply interchange rows and column. So the transpose of this matrix will be equal to, we shall have -1. This one, this column, this row becomes column. So it will be -1. We have 1, 3. Then we have 0, 3, 3, -1, 1, 0. Like that. And the transpose of this matrix is also equal to adjoint of matrix A. This is the adjoint of matrix A. Now, inverse of A is given by 1 over the determinant of A dot adjoint of matrix A. So inverse will be equal to 1 over determinant. Determinant was 3. Determinant is 3. Then we have the adjoint. The adjoint, which is this one. So it's at this times -1, 0, -1, 1, 3, 1, 3, 3, 0. So this is the inverse of matrix A. So we can open up we can multiply through, so that the inverse of A here we have minus 1 all over 3. We are multiplying through by 1 all over 3. Then here we have 0. Here we have negative 1 all over 3. Here we have 1 all over 3. 1 all over 3 times 3. So here we have 1. Here we have 1 all over 3. We are just multiplying through by this. Here we have 1. Here we have 1. Here we have 0. So inverse equals to this. But what was the equation? The equation says that A squared times A inverse is equals to A. Let us see that A squared times inverse of A must give us A. So we want to see. That's what they want us to show. Now, what is our A squared? Check. Our A squared is this. You can write it here. So we have A squared negative 2, 1, negative 2, 0, 0, 1, 5, 2, negative 1. And then we multiply by the inverse of A, which is times negative 1 all over 3, 0, negative 1 all over 3, 1 all over 3, 1, 1 all over 3, 1, 1, 0. 1 to multiply the 2 to see if we shall be able to get A. Remember A is this one, which is negative 1, negative 1, 1, 1, 1, 0, negative 2, 1, negative 1. So when we multiply the 2, we must carry this matrix. We will have been shown what the equation wants. Now we shall have negative 2 times. So we want to get this first element. So we shall have negative 2 times negative 1 all over 3 plus 1 times plus 1 times 1 all over 3 plus negative 2 times 1. So this equals to, so here it will be negative 2 and negative, here it will be positive, so here we shall have 2 all over 3 plus 1 times that, we have 1 all over 3, then minus 2. So here we have 2 over that. So this is the same as 3 all over 3. 3 all over 3 minus 2. So 3 all over 3 is 1. So we have 1 minus 2, which equals negative 1. Let us see now. We have negative 1. So we have gotten the first element. This second element we take, it will be negative 2 times 0. We have negative 2 times 0 plus 1 times 1, 1 times 1 plus negative 2 times 1, negative 2 times 1. So this equals to, this would be 0, 0 plus this is 1, this is minus 2. This minus 2. So we have 1 minus 2. So this is negative 1. So our second element is negative 1, which is that one. Then we go to the last element, this one. We take negative 2. So we have negative 2 times negative 1 all over 3, this one. Then plus 1 times 1 all over 3, 1 times 1 all over 3. Then plus negative 2 times 0. So negative, negative, and negative. So here you'll have 2 all over 3 plus 1 all over 3. Then here is plus 0. So 2 all over 3. So the LCM here is 3. 3 there, so we have 2 plus 1, which equals to 3 all over 3, which is equals to 1. So this is 1. Aha. So we are through with the first row. We go to the second row. We shall take now 0 times 1 all over 3. So we have 0 times negative 1 all over 3 plus 0 times 1 all over 3 plus 1 times 1 times 1, this one and that one. So of course this is 0, so this will be 0, this is 0, so we have 1 times 1, we have 1. So this will be 1. Is that one. We go to the next element. The next element, we shall take 0 times 0, which is 0, plus 0 times 1, which is 0, plus 1 times 1, which is 1. 0 plus 0 plus 1, we have 1. So this is 1. So we have that element. And then we go to the third element. We shall take 0 times negative 1 all over 3. We have 0 plus 0 times 1 all over 3. We have 0 plus 1 times 0. We have 0. So this is 0. We have that. The last row, we have 5 times negative 1 all over 3. We have negative 5 all over 3. Then plus 2 times 1 all over 3. We have 2 all over 3 plus negative 1 times 1. We have negative 1. The LCM here is 3. 3 there 1, so we have minus 5 plus 2. 1 there 3 times that, so minus 3. So this equals to minus 3 minus 5 minus 3 minus 8 plus 2 minus 6. So we have negative 6 all over 3, which is equals to negative 2. So this is negative 2, which is that one. So we move on to the next element. It will be 5 times 0, which is 0, plus 2 times 1, which is 2, plus negative 1 times 1, we have negative 1. So 0 plus 2 minus 1, this equals to 1. This is 1. That's fine. We go to the last element. It will be 5 times negative 1 all over 3. We have negative 5 all over 3 plus 2 times 1 all over 3. We have 2 all over 3. And then plus negative 1 times 0. We have 0. So negative 5 all over 3 plus 2 all over. So the LCM here will be 3. 3 there 1. So we have negative 5 plus 2, which equals to negative 3 all over 3, which is equals to negative 1. So this is negative 1. So you can see when we take a squared times a inverse is equals to a, and we have proved, which is this one. A is this, and when you multiply this and that, we get this one, which is a. Thank you for watching and listening.